Because why? I mean, the recoil is a little bit too strong, doesn't it? And it kind of picks up that little car and pitches it back into the roadway, which may not be overly desirable, especially if there's a big semi-truck coming right behind you, right?
Like this, you think?
But this system, though, has proven to be very effective. And if we can demonstrate here, hopefully, without getting Thor all wet. You nervous? No. No? All right. Thor's pretty relaxed. Since our last subject was shaking. So we'll see if our little crash cushion system works. All right, Sadie, let her rip. Thor?
Oh, so close. But did you get wet?
We just missed it a little bit off center.
Yep.
All right. So,
very cool.
Anyways, that's how we develop a system. You know, on live shows, you never know what's going to happen. It wasn't supposed to pop, but Thor, you survived. All right. Thank you, guys. We got a little present for you for helping us out here. All right. To put a wrap on our show here, we have just a couple more things that I'd like to mention. All right. So, yeah. So, yeah. All right. Are you awake? No? All right. So, let's just talk about a little bit how transportation engineering is changing. You know, what are the things that are changing now, both in terms of us at the university, as well as what you may see in the system. And one of the very first things that you may see is stuff related to simulation. So, in the old days when we developed transportation system, we just built it and hoped that it worked. All right? In today's day and age, and before you run that route, we can take a system like this, and this, for those of you, can you kind of see the football stadium there? And we're up in the engineering building. I should have had a laser pointer, but we're up in the engineering buildings here on Engineering Drive, and all those red lines are lines that we've gone out and collected data on that we can simulate. Okay? So we can decide how much traffic we want, and then we can put the vehicle movements on the roadway.
What's happening down here? What's going on? Is that something we look at?
What are you pointing at, Andy? Oh, all the queue development?
Yeah. So are these things that we kind of examine?
So we can see problems, can't we? So we can identify areas that aren't operating efficiently, where we're seeing backgrounds under different conditions or backups under different conditions, and make changes to that accordingly. All right? So simulation is very big now in everything that we do in transportation. We also use full vehicle simulation. So it's like the ultimate video game. We can put you in a car, let you drive. We can change the scenario around, both in 2D and 3D. We have a 3D lab here at the university, which makes things really neat. So we can create various transportation type backgrounds within the simulation in order for that to test. Transportation is also changing in many other different ways, right? So transportation is moving on to something. How many of you have seen segways?
Thanks, Bill, for coming today.
So little bumps doesn't seem to matter. Frontwards, backwards. So we have. Watch out for the crate. You got good balance.
Hey, I don't tip over.
No problem.
Weebles wobble, but they don't fall.
All right. So we see that we have all these nice new types of transportation systems to deal with. Now, what is that? So it's a Segway. Is he now a pedestrian? So is he a bicycle? Is he a vehicle? Where should he be? Sidewalk, bike lane, or vehicle lane?
Segway lane.
Where would you like to be?
Actually, I can be anywhere.
You can be anywhere. How fast can you go?
About 14 miles an hour. When I'm on the sidewalk, I must obey all the rules of a pedestrian. When I'm in the street, I must obey all the rules of a bicycle. And here in Wisconsin, the legislature passed a law that says I can also go on the bike path, and if there isn't a sidewalk, I can go on the roadway on a highway.
Huh?
Okay. So that's how yeah, go ahead.
Isn't there a minimum speed limit on our roadways?
This is legal on any roadway up to 25 miles an hour, so I cannot take this on a roadway that has a speed limit of more than 25 miles an hour.
But there is no minimum.
No minimum.
Okay, thank you.
Thank you, Bill.
So as you'll see, transportation now is really the key piece of any puzzle. So when we talk about, whoa, he can really go. Transportation, we find, and obviously we're a little bit biased, but it's a key piece of engineering. I mean, it's a key piece of everything we do on a daily basis. It's a key piece of how we get to the things that we need to the grocery store and to the stores and all the other freight and goods and services that we use. So obviously transportation is very, very important to the overall environment. So our message again to you, as you leave and you leave engineering today, wear your safety belts, slow down, and be smart on the roadway system. So again, our message from the kids. So hopefully some of you became interested in transportation today, and I would love to see you back sometime in a classroom here at the university.
If you have any questions, feel free to grab any of us in a red Hewitt shirt and feel free to stop at our booth, and we have a lab downstairs set up.
Okay.